Welcome to this GCSE lesson on nuclear physics. So let's start by looking at this picture. What is shown in this picture? I'll give you a moment to consider that. Now what we can see here is actually a picture of the Milky Way galaxy taken with a gamma ray telescope. Now notice a couple of very bright spots, in particular one at the far right of the screen along that orange band, and one further on the left but slightly below the orange band. And let's compare this to a picture of the Milky Way galaxy in visible light. Here you can see that we have completely different features that are visible in visible light compared to gamma rays. The gamma rays, in fact, are showing us nuclear reactions taking place deep inside the galaxy, and so can give us a huge amount of information about nuclear reactions that are going on throughout space. So today's lesson is on gamma rays. Before you start, can you name 3 types of ionizing radiation? State what happens to like charges and opposite charges when they are near each other. State the composition of a gamma ray. State what is meant by penetration. Compare the relative ionizing potential of all 3 ionizing radiations, and describe the mass and charge of a gamma ray. If you can't do this, you need to review the previous lessons on atoms, ionizing radiation, and the dangers of ionizing radiation. So we'll look at unstable isotopes first. There are many ways an isotope can be unstable. In the case of gamma ray emission, it shows that a nucleus is able to vibrate or wobble after emitting an alpha or beta particle. It is this vibrational energy which makes it unstable. This energy can be transferred out of the nucleus by a gamma ray. So following the emission of alpha and beta, the nucleus will be left vibrating or wobbling. It needs to get rid of this excess energy, and so it does so by emitting a gamma ray, which carries that energy away. It transfers it to somewhere else. Sketch a simple version of figure A to show the emission of a gamma ray from a nucleus, and state how the emission of gamma rays is caused. Figure A shows a vibrating nucleus with too much energy release a gamma ray to decrease that energy and become more stable. Gamma rays carry no charge or mass, so both the atomic number and mass number of the isotope stay the same. Explain why gamma ray emission does not result in a change in the mass number or atomic number of a nucleus. Let's take a look at the properties of a gamma ray. Gamma rays are very different from alpha particles and beta particles. They are uncharged and have no mass. It is not possible to deflect their motion using charged plates, which shows its lack of charge. Gamma rays are part of the electromagnetic spectrum, which means they're made up of a particle of light called a photon. These travel at the speed of light, and in the case of gamma rays have the highest frequency, highest energy, and shortest wavelength of all electromagnetic waves. So as you can see here, the gamma ray, as it passes between 2 electrodes, a positive and a negative, it carries on in a straight line without being deflected. Explain how scientists can show that gamma rays are not charged. Let's take a look at the penetration depth of gamma rays. Figure C shows that a gamma ray can pass through paper and metal foil, and it can only be stopped by a few centimeters thick of lead. Since gamma ray photons have no charge, they do not easily interact with charged particles and must collide with a particle directly. However, due to their extremely small size and zero mass, and the fact that atoms are mostly empty space, they rarely collide with electrons, so you need thick layers of dense material, like lead, with lots of electrons in a small volume in order to stop gamma rays. You can also stop gamma rays with a very thick sheet of concrete. Sketch a diagram of figure C. State the penetration depth of gamma rays and explain why gamma rays penetrate through most materials except Now it's important also here to note that gamma rays can pass through air with an infinite range. They are not absorbed by the air at all. So one use of gamma rays is sterilizing objects. Now many of our foods are irradiated with gamma rays in order to sterilize them. Foods like milk naturally contain bacteria which will spoil the milk over time. A very intense source of gamma rays is able to penetrate into the food, killing all the bacteria inside it and preventing the food from spoiling. The food will then last many years until opened, at which point new bacteria will enter and then spoil the food. This can also be used on medical equipment to make it safe for surgery. So it's very important to note here that irradiating food is not the same as contaminating it. When something is irradiated, it means that alpha, beta or gamma are passed through the material. But once that's happened, the alpha, beta and gamma are gone. They cannot cause any harm. That material is perfectly safe once there is no more source of irradiation. This is very different from contamination, where you may get some alpha, beta or gamma emitting isotope. So maybe you'll have polonium that's emitting alpha rays onto a food source or onto another thing that you may touch. This is called contamination. And contamination is very different from irradiation. Because if you contaminate something, that means you've put a radioactive substance on it that is constantly emitting ionizing radiation. Explain how a gamma ray source can be used to sterilize medical instruments. Explain why irradiating food is safe for the consumer. And finally, let's look at some problem-solving activities. State what happens to the atomic number and mass number of a nucleus when it emits a gamma ray. Use a periodic table to identify what element will be produced when the following nuclei emit a gamma ray: hydrogen 3, lithium 8, gallium 71 and krypton 85. And finally, for the isotopes in question 2, state their mass number and atomic number after the gamma decay. Now, if you'd like to read through the textbook page and attempt the problems this way, by all means pause on this screen and do so.